Hello.
Yeah, good evening, sir.
Yeah, good evening. What was the last thing we had discussed?
Sir, why, like
Did
radical
we
acceleration?
do Carnot's theorem we had done?
Which theorem, sir?
Carnot's theorem.
Yes, sir.
We had done the proof of that, right?
The locus one, yes, sir.
The proof of this theorem says that the perpendicular lines at from a point basically inside a triangle, if you draw three perpendiculars to the sides, they will be concurrent if and only if a certain condition is satisfied.
Hmm.
These three perpendiculars are going to be concurrent. If you call these points M and P, then the only way they are concurrent is MB square minus MC square, MB square minus MC square plus NC square minus NA square plus AP square minus PB square.
Hmm.
Basically, if that is equal to zero, then
Hmm.
only then these three perpendicular lines are concurrent.
Hmm.
We had done the proof of that, and I had asked you to work on proving a question which is about Bevan's point. This was the question. There
X
was a,
sentence. Yes, sir.
has anyone done the proof? Let A1, B1, C1 be the tangency points
Of X center.
of X circles with centers IA, IB, IC with the sides BCCA, AB.
Hmm.
Then the lines IA, A1, IB, B1, and IC, C1 are concurrent. That is what you need to prove, and this point of concurrency is known as Bevan's point.
Hmm.
Nobody has done it, right?
Sir, we should use the Carnot's theorem, right?
Yes.
I couldn't get any further from there.
If you know that you have to use Carnot's theorem, it's actually quite obvious after that.
Okay.
If you know that, then there is nothing else, that not much is left. For Carnot's theorem, what do you have to do?
We okay.
If this is the IA and the point of tangency is A1, it will be somewhere here. This is the point of tangency of the circle here. So that means obviously this line is perpendicular. IA A1 is perpendicular to BC. That is obvious.
Yes.
Similarly, IB B1 will be perpendicular to CA, and IC C1 will be perpendicular to AB. You have to prove that these three lines are concurrent. By Carnot's theorem, what is the condition? Right.
BA1 square minus CA1 square plus CB1 square minus B1A square plus AC1 square minus C1B square is equals to 0.
Can you prove that those distances? Can you find those distances?
Hmm.
Those distances are obvious to anyone who has done chapter 15 of SL only.
H minus A. Yes, sir.
What is this distance?
H minus C. Wait, sir, let me calculate. 1 minute.
What is this distance? Is
S
S
minus
minus
B. S
B.
minus B. S minus A. S minus C. And S minus B. That one. AC1. And
It,
this is S minus A.
it is clear that the Carnot's theorem expression will become zero because all the distances are symmetrical.
Hmm.
By Carnot's theorem, this is direct that these are congruent.
Hmm.
Do you
So,
understand what I'm saying?
hmm.
Yes.
You need to be able to prove that the distances are these, which is an easy proof. And that proof you need to know from SL only. When you make an X circle, where does it touch? How far is it from here? You should know that this is equal to this,
Yes, sir.
and this is equal to this.
Hmm.
And this whole distance, I think, will become S.
Hmm.
All of this is done in SL only. This distance is S, and this much is C. So this much becomes S minus C. So this is S minus C. Now, why is this whole distance S? That proof you have to know. Can somebody tell me why this whole distance will be S? Nobody has any idea why that distance is S. Basically, what I'm trying to say is the point where the X circle here touches from here to this A, how much is that distance? If you know that that distance is S, it is over because this much will become now S minus C because this much is C, right? So if you
Yes, sir.
know this much is S minus C, you know this much is S minus C. And then the theorem is done by Carnot's theorem. So all you have to prove is that A to this point is S. Basically, the way to prove it is that take double of that, let's call it P, take 2AP. 2AP is what? AP plus AP, right? Correct? And AP can be written as also AQ technically.
AQ. Hmm.
This is AP plus AQ, right?
Hmm.
For same point A से दो tangents बन रहे हैं, right?
Yes, sir.
And now AP can be broken down as AB plus BP and AQ can be broken down as AC plus CQ, and BP plus CQ is equal to BC.
Hmm.
You understand what I'm saying?
Yes, sir. Got it.
Yes.
So 2AP is basically 2S.
Hmm.
So AP is equal to S. And this
Hmm.
proof is very simple, and anybody who has done SL only knows it. In the derivation of X radii, he has just shown this thing. You need to know such things. These are obvious things. You understand everybody?
Yes.
इसमें कुछ भी मुश्किल नहीं है. Basic circle property से आ रहा है. Okay, we saw the main idea of what is radical axis and all, right? Did we discuss radical axis definition?
Yes.
What is radical axis?
Uh, it has the same power from both circles.
A locus of points P such that
The
it has
power.
equal
Yeah.
power
Hmm.
with respect to both given circles, with respect to two given circles.
Hmm.
Two given circles, let's call the circles C1 and C2. The locus of such points will be called the radical axis. It turns out that that locus is a straight line.
Hmm.
Now, because it has equal powers, we can say center of C1 is O1, center of C2 is O2, radius of C1 is R1, radius of C2 is R2. So power of P with respect to C1 should be power of P with respect to C2. So we can say O1P square minus R1 square should be equal to O2P square minus R2 square.
Hmm.
And from here we can say O1P square minus O2P square is equal to R1 square minus R2 square.
Hmm.
Or basically rewrite it like this: PO1 square minus PO2 square is equal to constant.
Hmm. Yes, sir.
In the last class, we had discussed that such a thing describes a locus.
Hmm.
In the last class, we had discussed the locus of points P, such that PC square minus PD square is equal to constant, where CD was a known given straight line.
Perpendicular. Yeah.
We had talked about this, that locus of points P which satisfies this condition is a line perpendicular to CD.
Hmm.
So you can see here that the radius is always fixed. So the right side is constant, and we are PO1 square minus PO2 square, right?
Hmm. Then it's perpendicular to O1 or C1, C2.
P is a line perpendicular to O1, O2, right? Or
Yes, sir.
actually, I should have written it C1, C2, but fine. Okay, I have called the centers as O1, O2, so it's fine. So P is a line perpendicular to O1, O2, the line joining the centers, right?
Hmm.
So basically what we have gotten is, if there are two circles, the radical axis is going to be perpendicular to this line, right?
So what is the use of this theorem? Like why we have created a radical axis?
Because it is very useful in many problems. And we have some applications of it also that we'll see soon.
Okay.
It has a locus of equal powers. There are many properties. First of all, we have it is perpendicular to O1. It. What is the use of anything? Matlab, what's the use of geometry? There's no use. There's no real
Hmm.
use to anything in maths. It's abstract concepts. We do it because we find interesting things. There is no use to all of it. The only use is that it is interesting and some nice properties are coming.
Yes.
ऐसा कोई यूज के लिए मैथ्स नहीं किया जाता है, मैथ्स किया जाता है क्योंकि इट्स फन एंड इट्स न्यू एंड इंटरेस्टिंग एंड वी हैव क्यूरियोसिटी। डायरेक्ट यूज कोई भी ऐसा नहीं है कुछ भी। Radical axis is this line. If the circles, by the way, we don't know where it is right now. Where is the line? We know it is perpendicular, but perpendicular, there are many perpendiculars, right? समझ
यस
में आ
सर।
रहा है मैं क्या बोल रहा हूँ?
हाँ मतलब इनफाइनाइट परपेंडिकुलर है तो वो एग्जैक्ट नहीं
कहाँ
पता
पे
हमें।
है अभी पता नहीं है, लेकिन there is a nice way to find that out. So first of all, you have to, there is a nice way to find it out, which we'll do first, and then we'll talk about the specific cases. So our problem is, where is the radical axis? Before that, we can say that if two circles are intersecting, the radical axis will be these 2 points, segment joining them, or the common chord. Why is the common chord going to be the radical axis? Because if you look at the point X and the point Y, definitely these points lie on radical axis. Why? Check the power of point X with respect to this circle, 0, right? Power of X with respect to circle 1 क्या होगा?
0.
Everyone should be saying 0 instantly. Why is it taking so long for people to realize this? If a point lies on a circle, power is 0.
हम्म।
If a point is inside the circle, power is negative. If the point is outside the circle, power is positive. ये
यस सर।
सबको पता होना चाहिए. The point X also lies on circle 2. So therefore power is 0 with respect to that also.
हम्म।
Is it obvious that X has equal power with respect to both circles?
यस सर।
So automatically we know X lies on radical axis. Similarly, Y lies on radical axis,
तो इस
right?
परपेंडिकुलर यस सर।
Now, two points uniquely determine a line. So if you know 2 points on the radical axis, you already know the radical axis. It's the
हम्म।
line segment joining X and Y, right?
यस
So
सर।
that automatically tells you that this common chord is radical axis and it is perpendicular to O1, O2.
हम्म।
So that also confirms for us that common chord is always perpendicular to the line joining the centers.
यस सर।
Is everyone understanding what I'm saying right now?
Yes.
So we know for intersecting circles, where is the radical axis? It's the common chord. If you take a special case of intersection where it is a contact of a touching contact, then radical axis will become common tangent.
या
Because the only difference between this and this is that X and Y become same point.
सेम पॉइंट।
X
पावर
and
ऑफ।
Y are identical and the power of those points is same with respect to both the circles.
हम्म।
The line through this is the radical axis because this is the only line perpendicular to this line. If you take
यस।
any other line, it is not perpendicular to O1, O2, so that cannot be radical axis, right?
हम्म।
Is everyone convinced that if the circles intersect, radical axis is common chord, and if the circles touch, radical axis is common tangent?
Yes, sir.
यस सर।
Yes, sir.
Yes, sir.
When you learn coordinate geometry, there will be a simple way to get radical axis also, which relies on these things, these two properties. So what you will say is circle equation is like this, circle 2 equation is like this. We have to make sure that the equations of the circles have X and Y coefficients matching. Matching, by that I mean the standard equation of a circle looks like this, which you will learn in 11th grade coordinate geometry. This is the standard circle equation. The other circle equation also you should make X and Y coefficients as 1 and 1. For example, circle equation could also have been given like this, right? This is also a circle equation. So you should divide by 2 everywhere to make it x square plus y square. Do you understand what I'm saying right now?
Yes.
हम्म।
Once you have made the x and y coefficients match in the two circles, all you have to do is subtract the two equations, which will automatically cancel the x square and y square terms, and you will be left with only 2gx minus 2g dash x, 2fy minus 2f dash y, right?
Yes,
Plus
sir.
c dash c minus e dash, which is clearly a line equation, and you can prove that that line is also perpendicular to the line joining the centers.
Oh,
And that line automatically, because it is the intersection of two circles, you are solving c1 minus c2 is equal to 0. That automatically assume you're solving the two equations, so that line automatically will pass through the points x and y here, or will pass through the common point here.
yes, sir.
So basically, our understanding of radical axis has already given us a way to find it also, and it has indirectly given us a way to find common tangent equation or common chord equation, which is just the subtraction of the circle equations, right?
Yes, sir.
Is everyone understanding what I'm saying right now?
I don't understand the variable f and g.
तुमने सर्कल्स नहीं पढ़ा होगा तो फिर नहीं समझ में आएगा अभी, लेकिन 2-3 महीने में जब पढ़ोगे तो समझ में आना चाहिए फिर। तुमने कोऑर्डिनेट ज्योमेट्री पढ़ा है सर्कल्स?
No, sir.
So then you will not understand it right now, but anybody who has seen these equations of circles knows what I'm talking about. Has anybody seen that in coordinate?
No, sir.
No, sir.
None of you have done any coordinate geometry.
I've done till pair of
No.
straight lines.
हाँ, तो next chapter में circles का equation, I
Oh,
mean, circle equation is pretty obvious. Like, what is the
x square plus
locus
y
of a
square.
circle? What is the locus that can describe a circle?
All the points equidistant to the center.
So if the center is taken as minus g and minus f, and radius is taken as r, which is equal to root over g square plus f square minus c. Here g, f and c are some constants. What will be the equation of the circle according to you right now? बताओ क्या लिखोगे equation of circle? It's the locus of all points x and y which are equidistant from the center, and the distance from this point should be this, right?
Hmm.
Yes.
So the equation would be distance formula of this to this is always
X
equal
plus
to
g whole
r.
square
You
plus
will say
y.
x minus minus g, so x plus g whole square plus y minus minus f, y plus f whole square is equal to r, right?
Equal to- Yeah.
That's the locus of points P such that they are equidistant from this point, and the distance is equal to r, right?
Hmm.
If you write this as g square plus f square minus c and square everything, you will get x plus g whole square plus y plus f whole square is equal to g square plus f square minus c. And if you expand it, you get x square plus 2gx plus g square plus y square plus 2fy plus f square is equal to g square plus f square minus c. G square, f square get cancelled, and you get x square plus y square plus 2gx plus 2fy plus c is 0.
Okay.
Basically, this equation means that the circle center is this, radius is this. That's what it means.
Okay, sir. So, but
But
how did you know that r is equals to the under root g square plus
हाँ,
h square?
यही पूछना था। R कोई भी वैल्यू नहीं हो सकती सर रेडियस?
मैं तुमको इस इक्वेशन को समझाने के लिए ऐसे बोल रहा हूँ, ऐसे थोड़े शुरू करते हैं। शुरू
अच्छा,
ऐसे करते हैं,
Yeah.
अच्छा, H और K पॉइंट्स हैं और R कोई कांस्टेंट है।
शुरू ऐसे करोगे और उसमें आएगा प्लस एच स्क्वायर प्लस के स्क्वायर माइनस आर स्क्वायर।
हम्म।
इसको सी बोल रहे हैं, इसको जी और एच बोल रहे हैं।
Okay. Yes, sir.
अभी मैंने इक्वेशन ऐसे लिखा था, जी और एफ क्या है मेरा, माइनस एच और माइनस के।
हम्म।
सी क्या है?
कांस्टेंट H.
C is this, right?
Hmm.
तो इस सर्कल का इक्वेशन दिस मीन्स अ सर्कल ऑफ सेंटर एच के रेडियस आर, राइट?
Yes, sir.
तो एच क्या है मेरा?
Sir, points है H और K.
बट फ्रॉम दिस इक्वेशन व्हाट इज द करस्पॉन्डिंग जी एंड एफ? इट इज
H
माइनस जी
okay.
माइनस एफ.
Hmm.
दैट्स व्हाट आई एम सेइंग, सर्कल सेंटर इज माइनस जी माइनस एफ.
Yes.
अगर ऐसा इक्वेशन में सी है, सी इज इक्वल टू दिस h square plus k square minus r square. So you can say r square is equal to h square plus k square minus c, right?
Yes, sir.
H
Yes.
square is g square and f square minus c. So r is
Okay.
root over g square plus f square minus c.
Hmm.
All of this is super obvious stuff. You learn it in your circles when you do circles.
Hmm.
The
Got it.
point is that if the circle equation is one of the equations, x square plus y square plus, let's say, 2g1x plus 2f1y plus c equals c1 is equal to 0, and another circle is given with x square plus y square plus 2g2x plus 2f2y plus c2 is equal to 0,
Okay,
radical
then we will
axis can be
subtract
found by subtracting.
C1 minus C2. Yeah.
If you subtract properly, you will be able to cancel the quadratic terms.
Hmm.
What I mean by properly is sometimes the circle equation can be given with some coefficients, right?
We can make it equal then, but
We have to
like
divide
eliminate.
by 3 and remove x square and y square.
Ah, got it.
If you subtract c1 minus c2 is equal to 0, that is your radical axis, or sometimes it can be common chord, sometimes it can be the direct common tangent, but it is always radical axis. Do you understand what I'm saying?
So I don't get it. Like, what is the meaning of subtraction? Like, are these two circles coinciding or what? Like geometrically, I was asking meaning.
तुम दो लाइंस को इंटरसेक्शन पॉइंट कैसे निकालते हैं, दो लाइंस का?
Solution उसका
व्हाट इज द मीनिंग ऑफ सॉल्यूशन?
like जो दोनों को satisfy करे point.
कैसे करते हैं सॉल्यूशन?
मतलब
दो
so like this.
इक्वेशंस को सॉल्व करके कुछ एलिमिनेट करते हो.
हाँ, yes sir.
यहाँ पे दो इक्वेशंस को साथ में सॉल्व कर रहे हैं टू फाइंड द कॉमन लाइन पासिंग थ्रू देम. दिस
अच्छा.
इक्वेशन इज अ क्वाड्रेटिक इक्वेशन. दिस इक्वेशन
Hmm.
वाज linear, you were getting points.
Hmm.
Now you are solving the two circle equations together to find the common line or common chord. Sometimes they might not even intersect, but the subtraction will give us this radical axis.
अच्छा, got it sir.
If you take two lines, you solve them and form a common point, right?
Yes sir.
यहाँ पे क्वाड्रेटिक इक्वेशंस को सॉल्व करके कॉमन लाइन टाइप का निकाल रहे हैं.
Hmm.
When you do this equation, it already carries information about the individual circles. अगर कोई दूसरा circles होता तो अलग equation आता.
Hmm.
So when you are doing this subtraction and getting a line equation, it's not like it is an arbitrary line, right?
हाँ, वो मतलब दोनों पे वो लाइन दोनों का कॉमन है.
अगर वो intersecting circles होता तो वो ये line है. अगर वो
तो वो
टचिंग
रेडिकल एक्सिस
सर्कल्स
थी.
होता तो वो टैंजेंट लाइन होता, और अगर वो
यस सर.
नॉन इंटरसेक्टिंग है तो ऐसा लाइन होगा. You can prove it
तो
very
सर
easily that the line that you get is perpendicular to the O1 O2.
हाँ, मतलब ये नॉन इंटरसेक्टिंग वाले में कैसे करेंगे? उसमें तो कर सकते हैं जो टचिंग और इंटरसेक्टिंग हो.
I am saying that non intersecting वाले में भी जो line equation बन रहा है, it turns out that that line equation is the radical axis. It's not have doesn't have to be an intersection. Do you get a linear equation if you subtract?
Yes, sir.
That
Yes.
linear equation should represent some line, right?
Online, right.
That line is radical axis.
अच्छा, इसका प्रूफ भी होगा मतलब सर, लाइक
प्रूफ भी होगा मतलब अभी प्रूफ, क्या चीज
नहीं,
का प्रूफ चाहिए?
इस केसेस में समझ में आ गया. जब वो इंटरसेक्ट कर रहे हैं तो जो कॉमन लाइन होगी वो तो रेडिकल एक्सिस ही होगी, तो हम ज्योमेट्रिकली प्रूफ कर सकते हैं दोनों केसेस में. और जैसे इस केस में जो हमें लाइन की इक्वेशन मिली जो दोनों सर्कल से टच नहीं कर रही, तो इसको हम परपेंडिकुलर कैसे प्रूव करेंगे, लाइक इक्वेशन और लाइन के
तो
साथ?
इस पॉइंट का इस पॉइंट का और इस पॉइंट का क्या कोऑर्डिनेट्स है?
-g -f और h और k। अच्छा,
क्या
-g2।
स्लोप है इस पे? बताओ इसका स्लोप O1 O2।
-g2 प्लस g1, नहीं,
गलत बोल रहे हो।
-f2 प्लस f1 अपॉन -g2 प्लस g1। हाँ, यस सर, यही।
What is the slope that you get on subtracting the line? क्या लाइन इक्वेशन आ रहा है? 2g1 - g2 x
x
2f1 - f2y plus c1 - c2. What is the slope of this line?
f1 -f2 अपॉन g1 -g2।
No, गलत बोल रहा हूँ।
G2 minus G1 by F1 minus F2
What is the product of that slope with this slope?
1।
minus 1.
1 नहीं है, -1 है।
हम्म।
तुमको पता है कि प्रोडक्ट ऑफ स्लोप अगर -1 है तो लाइंस परपेंडिकुलर है।
Yes.
सबको समझ में आ रहा है मैं क्या बोल रहा हूँ?
यस।
When you subtract the equation, you get a line that is perpendicular to O1 O2. It's very easy to prove. Just take the slopes, the product of their slopes is -1. But all of this is not the point of what we are trying to do right now. I was saying this just as a side thing. The main thing is something else. Main thing is we need to be able to find where the radical axis is, not by writing coordinate equations. We will find it by a better method. We are not going to always get the equations of the circles. Especially in geometry problems, nobody is going to give you that, right? So
यस
you
सर।
don't have coordinate geometry all the time to help you find the line equation. We have a way to find the radical center's location. We know that it's a perpendicular line, but where can we put it? So in order to find the location of that perpendicular line, which is basically telling us the locus of points with equal powers, right?
हम्म।
Basically, we are trying to answer the question that where will be those points which have equal powers with respect to two non-intersecting circles. So in order to understand that, we need to introduce the concept of radical center of three circles. What is all this? So let's say
दोनों।
we have three circles, λ1, λ2, λ3. In three circles, you can take three pairs, right? You can take three pairs of circles, correct?
Right.
If you take the circle pair λ1 and λ2, you will get a radical axis 1, 2, right? Which is a line, right? There will be a radical axis for this line circle pair. Similarly, there will be a radical axis for this circle pair. And similarly, there will be a radical axis for this circle pair.
यस सर।
It turns out that these three radical axes are always concurrent. The radical axis of pairs of circles out of three circles, RA1, RA2, and RA12, RA23, and RA13 are always concurrent. And that point of concurrency is known as radical center. So basically, this is a special point. If you have a system of three circles, तो तीनों radical axis जो बनेंगे will always meet at a point, and that point is the point which is equal power with all three circles. Do you understand what I'm saying? Obviously, because any point on this line is equal powers with which two circles? λ1, λ2, right?
यस
Yes.
सर।
Any point on this line is equal power with which two circles?
λ2 एंड λ3, तो
तो
λ1 एंड λ।
ऑटोमेटिकली अगर इन दोनों को तुम इंटरसेक्ट करोगे So the point of intersection of these two is actually going to be equal powers with all three.
तो वही जो point intersection होगा वही होगा हमारा point.
That means that it will definitely be a point that lies on this, right?
Yes, sir.
Basically, it's a simple proof to prove that there exists a radical center. It's not very difficult to imagine that there will be a point which is a radical center, right?
Yes, sir.
सबको समझ में आ रहा है मैं क्या बोल रहा हूँ?
Sir, but how do we prove that they're concurrent?
Prove what are concurrent?
RA12 and RA23 and RA13.
अभी तो बोला तुमने ध्यान नहीं दिया मतलब पिछले मिनट में.
Okay, so it's
Suppose you have three circles, 1 2 3. इन दोनों का एक रेडिकल एक्सिस है मान लो ऐसा, और इन दोनों का रेडिकल एक्सिस है कुछ ऐसा, राइट?
okay.
Any point on this line is equal power with which two circles?
2 and 3.
Hitesh, are you understanding what I'm saying?
Yes, sir.
Any point on this line is equal powers with which two circles?
2 and 3.
1 and 3.
1 and 3.
Okay, 1 and 3.
इन दोनों लाइन का इंटरसेक्शन कहाँ पे? ये जो पॉइंट है, is it special point in the sense that it is equal power with 1 2 and 3?
Yes, sir.
Yes.
Will it also lie on the radical axis of 1 and 2 now?
Yes, sir.
Yeah.
By definition it is concurrent.
Okay.
Is it obvious what I'm saying?
Yes, sir.
हाँ.
So now that we know that radical center exists for any three circles, that gives us a nice and easy construction of radical axis. Construction of radical axis for two non-intersecting circles. Intersecting circles का radical axis तो clear है सबको.
उनका तो क्लियर है.
नॉन इंटरसेक्टिंग सर्कल्स का केस समझना है कि कहां पे होगा. तो what you have to do is very simple. Create a third circle which cuts both these circles twice.
Twice. अच्छा.
मतलब this type of situation. यहाँ पे दो बार, यहाँ पे दो बार.
अच्छा, okay, then the intersection of the points, yeah, the respective radical axis. Then their intersection is collinear and that gives the position of
The
radical axis.
intersection of radical axis which is common chord and this common chord which is radical axis will be radical center, right?
Yes, sir.
So this point has to lie on the radical axis of the other two that you wanted. So now you already know centers तो ऐसा है, center वाला line you can already draw. Now draw perpendicular line through it. Does everyone understand what I'm saying?
Yes.
If you have two circles, the only question was where should we put the perpendicular lines, right?
Yes, sir.
So two circles were here. Where should we put our radical axis which is perpendicular to this? So what we need to do for that is make a third circle which cuts both of these circles however you want, as long as it cuts it at 2 points. Then you get a common chord here and a common chord here, which are the respective radical axis. तो यहाँ पे एक पॉइंट मिल गया जो radical center है. Through this point, draw a line perpendicular to this O1, O2.
Then it's radical axis.
That is your required radical axis for O1 and O2. So that is all you need for radical axis, radical center. More than this is not required. Then after
बाद भी कुछ है
this,
क्या?
हाँ,
इसके बाद भी कुछ है क्या?
नहीं, इसके बाद अभी कुछ नहीं है.
नहीं, अच्छा.
More than this is not required. You need to know this much and be able to use it appropriately. The next topics that we'll be covering are Sheva's theorem and proof plus trigonometric Sheva, Menelau's theorem and proof, and quadrilateral Sheva.
Oh,
So now we are going to start the topic of concurrency and collinearity. And that is a very important topic, especially in an Olympiad context. Sheva's theorem talks about concurrency of
Yes.
three lines, and
Hmm.
Menelau's theorem talks about
Collinearity
collinearity of
of
3 points.
3 points. Hmm.
And after we see all this, there is also a theorem that helps you convert from one to the other, which is basically a concurrency problem can be converted into a collinearity problem and vice versa, depending on whichever is easier. So there is Desargues theorem, which we'll do later. But first, you need to know the proofs of all these four things. First of all, you need to know the theorems and their proofs. So that is the homework. Find the proofs of all of these. Find the
Okay.
theorems, find the proofs. If
Okay.
you can do it, then great. Otherwise, we'll discuss it in the next class.
Hmm.
There are some applications of each of them that we'll see, but these theorems need to be super clear with their proofs. So
Got it.
work on it and find the proofs and all. All the proofs will come by simple similar triangles. So it's all understandable proofs as long as you know it.
Hmm.
So work
Sir,
on this part.
I have one request, sir.
Mhm.
Sir, वो कोचिंग स्टार्ट हो गई तो सर कैन यू प्लीज रिज्यूम क्लासेस फ्रॉम 9:30 ओनली.
Fine, that's okay.
थैंक यू सर.
Okay, that's all for now. We'll continue in the next class from this point.
थैंक यू सर.
Okay.
Hmm.
Thank you, sir.
Bye.
Thank you,
सर
sir.
Hmm.
सर मुझे कुछ बात करनी थी.
बोलो.
सर एक्चुअली ना मतलब जैसे अभी जेई वाले कोचिंग स्टार्ट हो रखे हैं
Mhm.
तो पापा बोल रहे थे कि ये मैथ्स ओलंपियाड मतलब नहीं करना है. तो जैसे हम तो अब घर से दूर हो आ चुके हैं
कहाँ पे आ
तो
गए हो अभी?
हम अभी दिल्ली में हैं.
घर कहाँ है तुम्हारा?
हमारा तो बिहार में है.
ओके.
मतलब हमने आकाश में एडमिशन ले रखा था. 9th
हम्म.
में लिया था. स्कॉलरशिप दिया था उन्होंने.
हम्म.
तो 2 साल ऑनलाइन किया फिर अभी 11th में ऑफलाइन. तो मतलब हमारा तो हमने बताया था आपको कि मतलब 9th 10th में तबीयत सही था नहीं. तो उस
हम्म.
टाइम उन्होंने कुछ ज़्यादा बोला नहीं. तो जैसे अब 11th स्टार्ट हुआ तो फिर उन्होंने बोला कि ज़्यादा मतलब प्रेशर लोगे मैथ्स ओलंपियाड साथ में जेई तो वो हो नहीं पाएगा. मतलब ज़्यादा फिर तुम्हारी तबीयत खराब हो जाएगी. तो उस वजह से
ठीक है,
मैं
इट्स योर.
मतलब
हाँ, ठीक है.
नहीं मैं वो आपको बता रहा था कि उस वजह से मैं पिछले 15-20 दिनों से मतलब वही ट्रैवलिंग हो रहा था और फिर मैं घर पे था नहीं. ना घर पे था ना मैं शिफ्ट हो पाया था. मैं मतलब या तो ट्रैवल कर रहा होता था या फिर मैं किसी रिलेटिव के यहाँ रुका रहता था. तो उस वजह से मैं क्लासेस नहीं कर पाया मतलब उतने दिनों से. और कुछ मतलब मेरा पूरा मैथ्स धरा का धरा रह गया था 20 दिनों 25 दिनों से. उससे
इट्स
पहले भी
फाइन,
बोर्ड.
तुम अपना रिवाइज कर लो. सारे वीडियोस तो यूट्यूब पे हैं ही, ये भी चला जाएगा. जो भी छूट गया है
हाँ.
तुम देख सकते हो.
नहीं मैंने देख रखा था बट मतलब वो स्टिल होता है ना वो फ्लो टूट जाता है तो थोड़ा सा.
टेक केयर ऑफ योर
हाँ.
हेल्थ एंड मेक श्योर दैट दैट इज द फर्स्ट प्रायोरिटी. कोचिंग वोचिंग चलता रहेगा, हेल्थ पे ध्यान दो और वो ठीक रखो.
हम्म.
और जितना भी हो सके करो, जितना हो सकता है. ठीक है.
हाँ. हाँ.
देर इज नो कंपल्शन. कोई चीज का जबरदस्ती नहीं करना चाहिए. जो हो
नहीं.
सकता है वो करो, और जितना देख सकते हो, जितना कर सकते हो उतना करो.
ओके थैंक यू सर.
हम्म. ठीक. बाय.